Nestled among the Swiss Jura Mountains is a town located in the canton of Neuchâtel, known as Locle. Its picturesque scenery has been one of the key backdrops of the leading craft of mechanical watchmaking for centuries. Our team has traveled thousands of miles to get a private tour of a brand's manufacturer that combines the traditions of this storied area while incorporating innovative technology that leads to the production of some of the most beloved watches by collectors in the world. Today we head inside Tudor's manufacturer. Cole, thank you very much for having us here at Tudor. This has been on our list for a long time. Before we head inside, can you tell us a little bit more about what we're going to be seeing today?
Well, firstly, welcome to the Tudor manufacturer. Behind us is a 5,500 square meter facility where all Tudors are produced.
In terms of how they're produced, we've seen many manufacturers in the history of this channel. What are some of the distinct touches that are unique to Tudor that we might see today?
Great question. So today we're going to see how humans and technology come together to make watches.
So Cole, we have a busy day ahead of us. Shall we start the tour?
We shall. Please, after you, sir.
So Cole, first stop of our tour. Where are we at right now?
This is the heart of the automated stocking system. So this is where the safe lies, which of course we can't see, but there's two components. There's the automated stocking system is the safe, and then a robot that assembles all the components in these trays, which have an RFID tag on it. So a watchmaker orders parts, it's assembled, and hands, the dial, the movement, all come on a tray like this. And this conveyor belt is actually built into the building, so in the walls, and it moves the components and then later the watch from station to station to station.
So for that tray, where will it head next? Where is it going its next step of the journey?
I'll show you. Let's go.
Okay.
So this is sort of the first step when it starts to look like a watch. So the automated stocking system assembles every component of a watch, and the watchmaker then orders those parts. So calls those parts, they're assembled on a tray and actually comes over here and picks up those trays of unassembled parts and comes to our main assembly floor. So it takes the tray from this automated stocking system, then brings it over to the assembly floor where we have work units of 4 watchmakers at each station.
So this is where you're infusing that technology with giving that watchmaker or technician the kit that they need to start this process.
Exactly. So the technology part is in the automated stocking system. Now it's handed over to the human part. And the human part starts right here. So once the watchmaker receives all the parts, that's when it's assembled. So this is assemblage, the assembly floor. So hands are fitted to the dial. Dial and hand composite is fitted into the case. It's cased up, and then it moves on to the next phase. So that is what happens at this area. Each bench is standardized. So these are work units of 4 watchmakers, with every desk being the exact same, so that any watchmaker can come, sit down, and they know exactly where their tools are. So this means, say someone is out sick one day, someone can jump in and fill in. And everything is absolutely standardized, and these units of 4 watchmakers can kind of act autonomously and move to a different function.
What about testing? Is there anything that's throughout this process being done to ensure that everything is done to code and how you know?
Yes, so every step of the way, the work is checked from the previous step. So you have at every single step forward, that's another kind of checkpoint in the process.
Is that testing automated? Is it a computer or is it by eye? How is that done?
So when the parts come in from suppliers, they're sampled to make sure they meet the technical control. If they do pass that check, then they're put into the automated stocking system, and then they're inspected at this station. Then the next station, they're inspected as well.
So the final stage here would be a fully cased up watch, then ready for transport. There's no bracelet, so it would just be the head of the watch, correct?
So the watch head goes back into that automated stocking system and will move in these walls. Literally, almost if you imagine like an HVAC system, so large corridors where usually air moves, imagine that sort of dimension, but instead conveyor belts. So there are conveyor belts in the walls here. So this means you don't have to take the watch and walk it to the next thing. You can focus on your task, making the watches. So you'll put the watch on the conveyor belt, it'll bring it to the next phase. So that's the last step on the assembly floor. So what country has the cleanest air in the world?
I would guess Switzerland.
It is Switzerland.
Okay, all right, good
And
guess.
as a bonus, when you buy a Tudor, you are actually buying a little bit of air, the cleanest air, cased up in a watch. So here, what we do is we keep a positive pressure environment, meaning that air is cycled through this space 2.5 times an hour, and the watch is cased up and it traps that Swiss air, right? And making sure that there's absolutely no dust in the watch. So dust is, of course, the watchmaker's enemy. That's why we're wearing these technician's cloaks, and that's why we keep a positive pressure environment here, so that when the watch is cased, there will be no dust inside the watch. Then, when you ship that watch to where it's going, the customer gets that bonus of having a little piece of Swiss air inside the watch.
It's not on the spec sheet, but just know
It's not. This is a little bonus, you know.
So Cole, we are
Yes, sir.
here in a very important aspect of the manufacturer. I'm not used to this.
Oh,
Who's
hello.
this?
This
All right.
is a robot that's kind of the de facto mascot of this METIS Master Chronometer Certification Testing Lab.
And obviously this is a crucial step for Tudor.
Yes.
To do this at scale is something that not many brands are able to do, and now you're expanding this out in a testing facility that also I would say is the most open you're going to be able to see in the industry.
Yes.
To being able to see how these tests are done. You hear the mystique about it. What is actually done in this
So
room?
there are 6 sort of key checks done. The first, which is pretty easy to check, is it Swiss made? So it has to be Swiss made.
Okay.
So can you confirm that yes, indeed, we are in Switzerland right now?
I can confirm that.
Yeah, okay, so that's the first one. Okay, great. Second is accuracy testing. So we have COSC at -4 + 6, but this turns it up to 0 + 5. So it has to meet COSC already, and then 0 + 5. And I should add, so these tests are performed on a fully cased up watch.
Yes.
And again, when it comes to nomenclature, we should clear up a few things too to make it sort of easier to understand. METIS is the governing body, a Swiss governing body, almost like the Department of Weights and Measures in the States. And the Master Chronometer certification is the certification applied to these watches. So METIS certified is really Master Chronometer certified, but we use those terms interchangeably, of course. And in this very space, on this floor, there is a METIS office that only one person, and maybe the security guard, has the key for, and that is the sort of liaison between METIS in Bern and in here. So their office, the function of that office is to oversee and make sure that all standards are being met.
So and that is a part of this space that is only operated by the Institute.
That's right.
Tudor has no insight into that.
No.
So can you talk a little bit?
Yeah,
I mean, I know we're
let's-
talking about many things, but
Sure.
we have a robot coming into frame. I'm not used to
Yeah.
this. This is the first time it's ever happened in the history of the channel. What is the robot doing?
Okay, the robot. So part of this idea of kind of technology and human power being leveraged is that, of course, humans can only perform their job while they're at work here. And we need to sleep, eat, and so forth. So the robot actually can continue functions that require simple things like moving watches from one station to the other while we all sleep. So that little robot you see going around is getting watches from one testing station and moving them to the next in an automated fashion. So it works around the clock. So while we're out of here, this robot is still moving around.
And some of the tests themselves are very much oriented around time, right?
Yes.
So if you're talking about a power reserve test, doing it at the right time in the wind, I don't know where he's going,
Yeah, I don't
juking out robots here, but you have to be able to specifically time that power reserve at a certain point in that uncoiling of that mainspring to ensure that it's going to pass that test.
Exactly. And then, right behind you is a magnet. So the final test, or one of the tests rather, is anti-magnetism. And this magnet is actually 15,000 Gauss. So for perspective, an MRI machine is 12,000 Gauss. So the watch has to be able to withstand that level of magnetism.
And the MRI machine, from my understanding, the Master Chronometer certification was partially, I'm getting spooked by this.
Yeah,
robot.
this is kind of crazy.
But it was set up because of the MRI machine, because there are enough clients that own watches that might be in day-to-day contact with the MRI machines.
That's
that
part
gives
of
you
it.
enough clearance.
And really, magnetism, like, that is the number one enemy of the functioning of your movement in daily life, right?
Absolutely.
So this is why this test is important. So if it can pass this magnet, so a fully cased up watch goes into a tray and then it is inserted into the magnet and removed, of course. If it can pass that, it could stand up to the rigors of daily life, like screens or the magnet latches on purses or whatever. You're walking by something with a magnet. This is the idea. So that's why we're testing it at 15,000 Gauss. Now you attach a strap or a bracelet.
So tell us a little more about this process. Comes from the Metas lab,
Yes.
comes here,
Yep.
through that automated system you're talking about, through the walls.
So yeah, exactly. Literally part of the building. Comes here, is picked up again, and each person is trained to actually do it for every single model. So there's polyvalence is a big theme here. One person being able to do multiple functions and train. So it takes about a month to 2 months to be trained on fitting a bracelet. So just something that we think is simple isn't actually that simple, because of course you want to guarantee that there's no scratches, there's minimal contact, and that there's consistency in the process of attaching the bracelet to the case. Additionally, you'll need to remove a lot of the stickers and protective elements that comes from the production side. So you comes in, remove the stickers, attach the bracelet, and it's not a. It sounds simple, but it is a very important part of the process.
And you've introduced many different bracelet concepts at this point. You have your 5-link, you have your 3-link design, so
That's right.
and you also have the different strap attachments as well that's being done here.
Exactly.
All that's done in this room.
And of course, one model can come on multiple configurations. It can come on a rubber strap, a bracelet, a leather strap, and so forth. So that's all in the system, and they'll produce to that order.
In my understanding, what else is done in this room? Engraving.
That's
And I'd
right.
like to make a point about this because I was thinking with somebody, they asked me, what brands can I think about for an engraving? And it's almost been a lost art.
Yeah.
Just even have an open canvas.
There's plenty of real estate to apply in engraving, and that's kind of the standard. Of course, some watches, the FXD, Marine Nationale being one of them, has, of course, MN and then the year of production and so forth. But we also do produce limited runs of special case backs. So we engrave case backs, especially for some projects, and I'll show you a few of them.
Sure.
For instance, this one is a watch that came out recently, which is the Black Bay Ceramic Blue. So there is actually an edition that was made for the F1 team. So the entire team was given one of these watches. And here we'll have the logo of the team, Visa Red Bull V-Carb.
And doing this on Sapphire. tab.
Exactly. So the machine, depending on the program, can engrave. It's a laser engraving machine. So it can engrave, we have case backs in titanium and stainless steel. So the program is written for each case back and each design. So this one is on Sapphire, but let's say this watch, which is actually made to celebrate the Campione d'Italia.
Pretty good.
That's
I'm sure an Italian viewer might correct us.
But yeah, that's okay. I'm just giving it a shot, you know.
That's all we can ask.
Of Inter Milan. So this case back features the Inter Milan logo, of course, and a special dial on the front as well. So all of that engraving is done here too, in the factory where everything else happens. The engraving happens as well.